Morning, good afternoon, good evening, depending on what time you are listening to this video. Today we are going to talk about graphing linear equations. But before we talk about graphing them, we need to talk about there are two forms of linear equations. The first form is what we call a standard form. And the standard form is always going to be in the format of ax plus by equals c. And the second form that we have is what is called the y-intercept form. And with the y-intercept form, this is where you're going to be, your y is going to be isolated on one side of the equation, and it's going to be y equals mx plus b. We are going to talk about this y-intercept form in a later video. So today we're going to deal strictly with the standard form. The very first thing that I want to go over with you with the standard form is on many standardized tests, you're given an equation and then asked if a point is a solution to that equation. For example, let's look at the equation 3x minus y equals 7. And I want to know if point 3, 4 or 1, negative 4 is a solution to this equation. As we learned in a previous class, all coordinate points come in an xy form. So all we need to do is take these points and substitute them into the equation and see if they make a true statement. For example, I'm going to work with the point 3, 4 first. So I'm going to go ahead and substitute 3 in for x minus 4. I'm going to substitute 4 in for my y. And then I'm going to see if this is a true statement. Well, 3 times 3 is 9. 9 minus 4. So 9 minus 4 is going to give me 5. And 5 does not equal 7. So 3, 4 is not a solution for this equation. Okay? So now let's check point 1, negative 4 and see if it is a solution. So what I'm going to do with this one, I'm going to do exactly the same thing. I'm going to go 3 times 3 times 1 minus, and I'm going to substitute negative 4 in for this one. And this time I'm putting a parentheses around my negative 4. And I'm doing that because I already have a negative sign in my equation. So now I'm going to do my math. 3 times 1 is 3. A negative times a negative is going to give me a positive 4 equals 7. 3 plus 4 is 7. And 7 does equal 7. So the point 1, negative 4 is a solution for this equation. Okay? So the next thing I want to do is, that should be a little bit of a review for you for finding out if points are solutions. The next thing we're going to do is we're going to actually graph an equation in the standard form. And the equation that we're going to graph right now is going to be negative 2x plus y equals negative 3. Now, as I mentioned during class, we're going to make a table and we're going to create our table. I do it vertically. You may use horizontal, whatever makes you easier for you. And I like to choose negative 2, negative 1, 0, 1, and 2. And then now I'm going to substitute this in and then graph my equation. So negative 2 times negative 2 plus y equals negative 3. That's going to give me negative 7 for my output. Negative 2 times negative 1 plus y equals negative 3. That's going to give me negative 5. Negative 2 times 0 plus y equals negative 3. That's going to give me negative 3 as my output. Negative 2 times 1 plus y equals negative 3. That's going to give me negative 1 as my output. And then, last but not least, 2 times negative 2 plus y equals negative 3. And with this input, I'm going to get the output of 1. So now I have all my ordered pairs. I have ordered pair for this one is going to be negative 2, negative 7, negative 1, negative 5, 0, negative 3, 1, negative 1, and 2, comma 1. And so now all I'm going to do is go up to my graph and I'm going to graph these points. So I have negative 2, negative 7. I'm going to go negative 1, negative 5, 0, negative 3, 1, negative 1, and then 2, 1. And so now I'm going to join all my points. And that is the graph for negative 2x plus y equals 3. Okay? Now, when we graph linear equations, we have two special linear equations that we need to talk about. The first one is horizontal lines. And with our horizontal lines, we're going to talk about horizontal lines are lines that when graphed, they're going to be a straight line going from left to right. Horizontal graphs will always be in the form y equals some number b. In the example that I'm going to do for you today, we're going to use y equals 2. So all you have to do to graph y equals 2 is go onto the y-axis, and what I want you to do is put a dot on 2, and at this point all you have to do is draw a vertical line through that point, and there is your graph y equals 2. If you want to check to see if you graphed it correctly, you can choose any point on this line. For example, I'm going to choose this point, which is negative 2, 2. I'm going to choose this point here, which is 2, comma 2. I'll choose this point here, which is 5, comma 2. And if you'll notice, everywhere I choose a point on this line, my y equals 2. Okay? The second type of special equation are vertical lines. So we're going to talk about vertical lines now. And these equations will always be in the form of x equals some number a. For example, we're going to graph x equals negative 1. Okay? So these lines are going to be vertical lines, and so they're going to look just like that when I graph them. So what I'm going to do is go on to the x-axis this time, and I'm going to locate negative 1, and I'm going to put a dot on it, or a coordinate point, and I'm going to draw my graph through that coordinate point. Okay? And just like my horizontal line, if I want to check to see if I got the graph correctly, I can choose points on here. If I choose this point here, this is negative 1, comma 2. Let's say I want to choose this point. This one is negative 1, negative 2. If I want to choose this point here, this is negative 1 and 5. But no matter where I choose a point on that graph, your x will always be negative 1. Okay? So, the next thing we want to do is I want to graph another line for you, but this time I want to show you a graph of an equation that's in the y equals negative 1/2 x plus 4 form. Okay? Again, for the purpose of this video, we're going to go ahead and make a table, okay, x and y. And what I do recommend to you is, because we're dealing with a fraction as our coefficient of x, what I want to do is I want to choose numbers that are products of 2. If I do that, my y's will always be whole numbers, and it'll be easier for you to graph. So I'm going to choose 0, 2, 4, 6, and 8. And I'm going to do exactly the same thing that I did in my first equation. So what we do is we're going to just substitute numbers now. Y equals negative 1/2 times 0 plus 4. Well, 1/2 of 0 is 0. 0 plus 4 is 4. So now y equals negative 1/2 times 2 plus 4. Well, negative 1/2 of 2 is negative 1 plus 4 is going to give me 3. Then I'm going to go y equals negative 1/2 of 4 plus 4. Well, negative 1/2 of 4 is negative 2 plus 4 gives me 2. And so I'm going to keep doing this. Y equals negative 1/2 of 6, which is negative 3, plus 4, which is going to give me 1. And then y equals negative 1/2 of 8 plus 3, which is going to give me 0. If you'll notice that I have a negative 1/2, which is my coefficient of y, which means that if you'll notice my y's are decreasing as my x's are increasing. So when I graph this line, I should have what we call a negative graph, okay? So I'm going to come over to my graph and I'm going to graph these. I have 0 and 4. I have 2 and 3. I have 4 and 2. I have 6 and 1. And then I have 8 and 0. And then now that I have this, I can go ahead and graph my line like that. Okay? Everybody good? Now, let's look at a problem that's dealing with linear equations. So, I chose this problem because it's going to be fairly easy for us to do. We're running the distance d in miles that a runner travels is given by the function or the equation d equals 6t. Distance equals 6 times his time, where t is the time in hours spent running. The runner plans to go for a run for 1.5 hours. Graph the function and identify its domain and range. So again, for the purpose of this video, we're going to go ahead and create a table where we have x and y. But this one, we don't use x and y because they've already told us that they want us to use the letters t and the letter d for distance. So I'm going to go ahead and change my graph, okay? And so we're going to go ahead and do this. So I chose, well, at 0, he's traveled 0 miles, right? Then I chose at half an hour, okay? Well, 1/2 of 6 gives me 3. Then I chose at 1 hour, okay? And 1 times 6 gives me 6 miles. And then my next graph, I chose 1.5 because that's where they want me to go. And so 1.5 of 6 gives me 9 miles. So now all I have to do is graph this equation. So we have 0, 0. We have 1/2 and 3. Then we have 1 and 6. And then we have 1.5 and 9. Okay. So our graph is from there to there. Now, we've got to deal with this. We got to identify the domain and range. Okay. So all we need to do is go domain equals. Well, your domain is your x values. So we know that my domain is from 0, okay? But in this case, we're not using the letter x because they want us to use the letter t. So t is going to fall between 0 and 1.5, okay? Because that's the time. So your domain is going to be these numbers. And then your range is going to fall, same thing, it's going to fall between 0, and this time we're going to use the letter D, so it's going to fall between 0 and 9. So that ends our lesson today. I thank you very much for listening and take care.